All right, we're back with another Azure in the Enterprise. I'm Lyle Dodge. Today I have with me Rajesh Vasareddy. Rajesh, nice to see you again.
Nice to meet you.
So today we're going to talk about one specific thing in the SQL PaaS platform, but you're from Microsoft IT. Can you give us just kind of an idea of what we run in Microsoft IT for the data platform?
Yeah, like any other enterprise, we do have our supply chain marketing sales, and have all these applications relying on the native SQL instances over a period of time. With the cloud disruption, SQL PaaS is our obvious choice. So we're a huge Azure SQL DB PaaS database shop.
So we've got a couple of SQL servers on-prem, a lot of SQL on IaaS, and we're heavily using SQL PaaS. So that's the Azure SQL database. We're using that left and right.
That is correct.
And so what I wanted you to talk to us, and especially our enterprise customers today that are looking at SQL PaaS, is one specific feature on that, and that is the auto-tuning feature of SQL PaaS. So can you just tell us a bit quickly what that is, and then we're going to actually show some results of something that you did.
Absolutely. So Azure SQL DB, being a platform as a service offering for the native box product, had a lot of intelligence built into it, and one of the outcome is the advisory. Advisory means platform look at your usage, some metadata is good enough to produce actionable recommendations, and by default it will provide you an advisory when you go to the Azure portal. And there's an optional setting that you can trust it to go ahead and implement it without you being reactive to this advisory and pushing a button to implement it. You can turn on a setting called auto tuning that exists for every Azure SQL DB as well as a logical server setting, so that it go ahead and implements recommendations.
And so, we're looking at this graph here. So today we just have create index and drop index. Those are the first two that they've released. So can you walk me through what we're looking at here?
Yeah. So 2 weeks ago we executed a big batch of one of our business units, a critical business units, where we collect all the subscriptions that service all the applications for the entire business unit, and we turn on auto tuning by default across all subscriptions. And in total, we cover approximately 348 servers with 829 databases, and turn on auto tuning. So the good thing is when you turn on auto tuning, we can see the effectiveness of each of the implemented recommendation, and the service plane is capable of generating recommendations, implementing the recommendations, and capable of detecting regression, and can revert on its own if an implemented recommendation started exhibiting regression that outweighs the benefit of the recommendation.
So we look here, we over the past 2 weeks, it's created 2,200 indexes. It rolled back 300 of those. But it still did a bunch, and then over that same 2-week period, it dropped 5,700 indexes across those 800.
Yeah, isn't that amazing? Just imagine the world where every index, developers bake the functionality by putting some index, move the application to production, and you have a new workload patterns that the existing indexes may not serve the purpose, and actually most of the times they turn to be overhead. So we often do this index management being a reactive when performance drops or something, and you have to fight for almost like 15 days with all the teams involved to either add an index or drop an index. But here, by just turning on auto tuning in the last 2 weeks, as I said, it dropped 5,700 unused indexes, and there is a hard to beat definition on why this index can be dropped. And it is capable of, as I said, detecting regression and see how many reverted out of the 5,700 dropped indexes. It only reverted 97, which means it recreated those indexes because it felt that there's some workload after dropping the index, missing that index, so it recreated it back. So it is completely safe.
So then you can see here, one of the other things you have in here is it improved over roughly 4,000 queries. And so, especially for enterprises that are migrating a database over to SQL PaaS, the workloads have changed over time. This is improving everybody's experience. So
it is. This advisory is all about giving meaningful recommendation with a view to enhance business experience by pushing the performance and reducing the resource consumption. As you see here, almost 4,000 plus queries got a positive enhancement on its performance and consuming lesser resources. And there's a slight number of queries that undertook regression, and that's why you see a correlated number of approximately 300 indexes created has been reverted. So just imagine 4,000 dynamic SQL queries and how many man hours it will take for you to to see out of this dynamic SQL coming in, which one index is going to give the most benefit. At the same time, you cannot create all the indexes for all those 4,000 or 5,000 queries, right? So
you can see here, you in your a couple of these queries really got some massive benefits. In addition, you did some measuring to see kind of, roughly ballpark what the resource drop is over the 2-week period. So, can you walk me through this chart here?
Yeah, often we see that an Azure SQL DB, when you buy it, each SKU comes with a DTU, and the DTU is a combination of CPU, memory, I/O. CPU is the obvious factor that most of the times we see that pushing the DTU. And after implementing these recommendations, we see on an average 257 CPU hours has been reduced. You might not realize that as a huge number, but when it's spread across tons of databases, it's good enough to push the data tier to database tier from a higher level to lower tier in most of the cases.
That saves a lot of money.
Yeah, that saves a lot of money. At the same time,
and not only are you saving money, but the people that are running the workloads are experiencing better performance.
Absolutely, because you no longer have the noisy neighbor contention. You have less resource consumption, so that you're enabling your peers to use those resources in spare, and ultimately results in a much better enhanced performance.
And so, what does this create index drop index over here in the top right corner?
So, the main concern that anybody will have that when I let somebody create an index, first of all, is it the right index and how much space it's going to consume, because space is also a factor baked into your SQL elements. So this graph shows that of all the 2,200 indexes added, the total capacity that it additional took is 368 GB across 800 databases. So it's not that much, because at the same time, when you drop this,
a third of a gigabyte of database, something like that.
Yeah. If you take a P11, probably that's 1/3 of the size, but that's for 900 approximately 900 databases.
And you save some space on your drop index.
Yeah, those are the data, just the indexes sitting there doing nothing. They are not contributing at all. They are never touched in that long time. We know the definition internally because we took part in engineering this function, so we know the hard to beat definition. So they are absolutely safe to go ahead and drop it.
And so, what's this daily logical reads down here?
Yeah, after the CPU, the other significant factor is your reads, because when you have a query running, most of the times we see I/O being the bottleneck. And because you have a query that is doing a huge scan and doing a lot of reads. By putting the right indexes there, you're reducing, you possibly can reduce achieve the same operation with a less read operation. So if you look at it, this is a chart drill down on implemented recommendation. The first one, if you see it, how many? Probably it saved some. Yeah, it reduced those many logical reads by just putting that one right index there.
78 billion.
Yes, and I cannot count this number. If we sum up all the graph on the right shows that all the logical reads that are reduced after we implement this recommendation. Count the number.
Yeah, so you're looking at 263 billion logical reads a day, just by letting the platform
So which means you're getting the same result set by doing these many lesser reads. So that automatically translates to your lesser resource consumption, significantly improved end user experience.
And this doesn't mean, that the DBAs are terrible. This doesn't mean any of that. This just means that, hey, we have databases.
Yeah.
We can't predict how the workload's going to be day over day, month over month, year over year, but let's just trust the platform to go ahead and do it.
There's no way that even 10 DBAs, core DBAs, might just sit for a month and still cannot find out the 2 indexes that can cover the most of the benefit, right? Because it is impossible. You have diversified patterns of workload coming in, and there's no one index that's a magical bullet that works for all. So here we're trusting the platform because it knows what is that one index that got the most benefit. It will show you after a bunch of validations, this is a high impact recommendation. Go ahead and trust it and turn it on.
Okay, so when our enterprise customers that are watching this, they can go to the Azure portal. They can go either at the server, turn on tuning at the server level, or they can turn on to database level.
Yep.
They can also turn it on to database level and say don't inherit. So if for some reason somebody doesn't trust it, but it's like, this is pretty crazy.
This is very easy to configure.
Which business unit is this?
It's for core finance.
Okay.
This is our 5th business unit. We started turning it on probably in the last 6 months. We're working on this feature from last 1.5 years when it is in pilot, doing the engineering work on recommendations. So we saw this service evolve over a period of time. It is matured enough that we believe we just go ahead and turn it on.
So you just turned it on across 348 servers in finance, 830 databases, which, I don't see anything that says which is production or dev. So
to be honest, no, we don't even measure how many of these production. Probably 1.5 years ago, when we were piloting, probably we would have started you at first and see. Now this service reached to a sophisticated level that we just turn it on by default. The only parameter we supply is subscription IDs. We don't even know which are production.
So a great thing for an enterprise would be maybe like set an Azure policy that if you're creating a SQL PaaS database, just turn it on by default.
Absolutely. It had all the safeguards built into it. It is capable of detecting regression. It cannot overrun your resources. It have intelligence baked into it when is the right time to implement those recommendations. So
it's not going to go right in the middle of a quarter end run or anything like that.
Yeah. So that makes it, why not?
Yeah.
I don't see a reason why any enterprise cannot turn this on by default. And to be honest, I know a matter of fact that very soon we might see this as a default setting that the product might offer.
Why not? So I know after this you're going to help turn it on for the rest of IT, and I know you're in talks with the SQL product group. You guys might do more pilots across all the divisions of Microsoft. So
there's a lot more features other than just index and dropping, create and dropping indexes. There's a lot more coming on the way, but these two are like production ready. We're running it for a long time, and see probably so far for all the 5 batches we might have implemented some 15,000 recommendations. And we were yet to receive a single incident from any user complaining that, hey, something happened. And we are often pleasantly surprised, hey, I'm struggling to identify why my job all of a sudden started running fast, and I don't know why.
Stop complaining, let it run faster.
Yeah, so that's a pleasant surprise, right? So we trust this to this level, and we want to implement it across Microsoft internal consumption.
Okay. Well, Rajesh, thanks for your time today. I'm sure we'll see you again. I'd like to do this again in a few months here once we've rolled this out and see what happened across all of IT.
Sure. Thank you very much for allowing us to tell this great story.
And so here's an action item. Go to the Azure portal on your SQL Azure databases. Production dev test, doesn't matter.
Yep.
Turn it on. We'll come back in a few months and we'll look at what this means for all of MSIT.
Yep.
And we'll see you on the next Azure in the Enterprise.